The question says that potential energy function of a particle executing linear simple harmonic motion is given by expression Vx equals to kx squared by 2, where k is the force constant of the oscillator. Now for k equals to 0.5 Newton per meter, the graph Vx versus x is shown in figure 5.12, that is this figure. Show that a particle of total energy 1 joule moving under potential must turn back when it reaches x equals to plus minus 2 meter. So we all know simple harmonic motion, that is a particle, it stays at mean position and it goes to extreme position and then comes back, again go to extreme position in other direction and then again turns back. So we have to prove that the extreme position is at x equals to plus minus 2 meter. Now here we haven't given the potential energy function, that is kx squared by 2. So one of the definition of conservative force is that it can be derived from a scalar quantity, the potential energy, which is a scalar quantity. As per the question, Vx or the potential energy is given as kx squared by 2. Now derivative of Vx or the potential energy function that is given with respect to x is kx, or the fx according to the definition, where fx equals to minus of dv by dx, where v is the potential energy function, is minus of kx, which is the spring force which is responsible for simple harmonic motion, and it is conservative in nature. The point of talking about conservative force is that for a conservative force, the total mechanical energy of the system is conserved. When we decompose total mechanical energy in kinetic energy and potential energy, it is always going to be constant, whether the particle is at extreme position or the mean position or in between these two positions, it is always going to be constant. So we have to talk about the particle at x equals to 2 meter. So according to the expression of potential energy at x equals to plus minus 2 meter, here the sign won't matter because x is squared, will be equal to k is 0.5 Newton by meter. So 0.5 times x is 2 squared by 2, and that will be equal to 1. So once again, if we write this expression substituting the value of total energy and potential energy, we will get that total energy, that is 1 joule, equals to kinetic energy plus potential energy. Potential energy is again 1 joule. So we saw that at x equals to plus minus 2 meter, the potential energy is at 1 joule, which is equals to total energy. So kinetic energy must be equal to 0 in this case. Now when the particle will go beyond x equals to 2 meter, then obviously potential energy will rise, which will contradict the theory that total mechanical energy of a system is conserved if forces doing work on it are conservative. So that's why it can't go beyond x equals to 2 meter, because it will lead to rise in the value of potential energy, which can't happen as total energy is already given, that is 1 joule. So the particle must turn back from that point, and while turning back, the kinetic energy will rise from 0. Thank you.